Okay, here is page 2 of the review. So here it says the parent function is shown. Use the parent function to graph g of x. And so g of x of 3 sine inverse of negative x plus pi over 2. So all the sections here. So we need to go multiply the y value. So we need to multiply the y value times 3. And we need to move the y value up pi over 2. And then here says we need this is a horizontal, so this is a horizontal, actually the vertical reflection. We're flipping over, wait, nope, scratch that. It's a horizontal reflection. We're flipping over the y-axis. Horizontal reflection over the y-axis. So here's the point here. Our y value, which is pi over 2, we're going to times it by 3. So pi over 2 times 3 is 3 pi over 2. And then we're going to add pi over 2, which is right there. Oh, so nope, don't use that one. And then we got it horizontally reflected after that to be on that side there. Okay, at 0, 0, we're going to move it. 0 times 3 is 0, plus pi over 2 is up to right there. And then a horizontal reflection does nothing on the y-axis. And then finally this one right here, negative pi over 2 times 3 is negative 3 pi over 2. Plus pi over 2 moves it up to negative pi, and then a horizontal reflection over right there. So we end up getting this graph right there. Okay. This next one, so we are going to, this is the y value times 2. And then there is no vertical shift, and this will be the x value, and we're going to add 3 to it because we have to go in the opposite direction. So we want to go 3 in this direction to the right. So let's start with this point right here. So 0, the y value is 0, times 2 is 0, so that stays there. And then I add 3, 1, 2, 3, 3 to the right. Okay, at pi over 2 here, or at 0 pi over 2, the y value is doubled, so pi over 2 times 2 is 2 pi over 2, so that's pi. And then I move over 3, 1, 2, 3, to right there. And then this one, pi times 2 is 2 pi, and then over 3, 1, 2, 3, right there. So that is what our new graph looks like. Kind of make that a better arc there. There we go. And finally we have the tangent graph. So tangent here, we are going to reflect it vertically. So this is a vertical reflection, a negative out here. And then we're going to have a down. This is down pi. And there's no horizontal shift at all, nothing messing with the horizontal. So we just have to vertically reflect and then go down pi. So here, 0, 0, vertically reflect, does nothing. And then we go down pi to right there. Okay, this next one, so let's pick, this looks about halfway in between. So we're going to vertically reflect, so that goes to right here, and then down 3. 1, 2, 3. Wait, where'd I go? What? That there. 1, 2, 3. Yeah, right here. That's not right. Vertically reflect. Oh, sorry, not down 3, down pi. Vertically reflect, down pi. Pi is 2 blocks, so 1, 2. Yeah, right here. Not down 3. Ignore that one. Okay, and then here, this is vertically reflect up here, and then down pi to right there. Vertically reflecting the asymptotes, we'll put it right back at the asymptote, and then we go down pi. 1, 2 to right here. So here is one of the asymptotes, and this one vertically reflect down. This one vertically reflect down pi to right here, so it'll share that one still. So you end up getting something like that. There we go. Okay, number 11. Find the inverse of each function and list the domain and range of f inverse of x. So this right here, that is the domain of f of x. That's the domain of our original. Our range of the original, is the minimum to the maximum. So it'll be the min to the max. The minimum is the midline, which is -5, minus the amplitude, 2. So our minimum is going to be -5 minus 2, and our maximum is the midline plus the amplitude, -5 plus 2. So that means that our range is -7 to -3. But that's of the original, not of the inverse. Okay. Now, if I want the domain and range of the inverse, so the domain of f inverse is going to be -7 to -3. The domain and ranges switch. The range of f inverse is -pi/2 to pi/2. So there is our domain and range of f inverse. Now let's find the equation for f inverse. So starting here, we swap x and y. So this will be x equals 2 sine of y minus 5. Add 5 to both sides, and you get x plus 5 equals 2 sine y. Divide both sides by 2, and so you get x plus 5, well, times 1/2 equals sine of y. And then you take the inverse sine of both sides, so we have inverse sine of 1/2 x plus 5 equals f inverse of x. We'll swap that y to be f inverse now. And so there is our inverse equation. If you put x plus 5 over 2, that is also fine. I prefer this way, just so I can see what a is. You can see the vertical stretch a little bit easier, and you can see the horizontal shift a little bit easier. Or horizontal shift, horizontal stretch is what I meant. But up to you. It's preference. X plus 5 over 2 is fine as well. Solve the equation for 0 to 2 pi. So this one, we're going to start by subtracting 5 from both sides, and we get 2 sine theta equals -1. Divide both sides by 2. Sine theta equals -1/2. So between 0 and 2 pi on the unit circle, when is sine of theta -1/2? Well, that's going to be at pi to the over 6's. So -1/2 will be 7 pi over 6, quadrant 3 and quadrant 4, and 11 pi over 6. On this one, I have, this has a cosine squared plus theta plus cosine theta equals 0. This is a quadratic, so I'm going to factor and then use those factors to find the zeros. So factor this out. We'll have cosine theta times cosine theta plus 1 is equal to 0. Now I have two numbers multiplied to be 0. One of them has to be 0. So case 1, cosine theta equals 0, or cosine theta plus 1 equals 0. So inverse cosine of 0. So when is cosine 0? Cosine 0 at pi over 2 and 3 pi over 2 is when cosine is 0 on the unit circle, 0 to 2 pi. And then cosine of theta equals 1. When is cosine 1 on the unit circle? It only happens at -1. When is it -1 on the unit circle? Happens one time at pi. So our theta is pi over 2, pi, and 3 pi over 2. There we go. Find all approximate values using the calculator. So make sure we do all appropriate values. We need to find the reflection cases as well as the calculator cases. So here we go. We're going to start by we get x by itself. So let's move 5 over. So we'll subtract 5 from both sides to get 5 sine squared x equals 5. No, 3. Sorry, 3. Divide both sides by 5 and you get sine squared x equals 3 over 5. Square root both sides and you end up with two cases. You have sine of x equals square root of 3/5, square root of 3/5, and you'll have sine of x equals negative square root of 3/5. So plus or minus 3/5. Then we get our calculator, which I hope I brought home with me today. Hey, I did. Awesome. Okay, battery's low, but we'll see if we can make it work. So we want to type in inverse sine, second inverse sine of the square root of 3 over 5. So we get 0.88. So for x equals 0.886. But this isn't the only solution where this is true. This happens twice, so we need the horizontal reflection, which means we need to get the horizontal reflection. And for sine, if you recall, if I have an angle here for sine, it has an equal angle on this side. So if this is theta, I also need this one. So this will be pi minus theta. So I need to do second pi minus this number right here. So we'll also have 2.256. So there are two of the solutions. And then I need the negative solution. So we will insert a negative in here. And we get negative 0.886. And then we want the reflection as well. Actually, that is not between... Oh, all approximate. Okay, we'll get that second. I need the reflection version of this as well. So I'm going to take second pi and subtract that right there. So I get pi minus that angle is 4.028. So these are my four different answers, and then each one of them would need plus 2 pi k on them, because we want all solutions. So we need the reflection cases, and we need this plus 2 pi k on each one of them. So there we go. There are our four solutions. So tangent. When is tangent squared x minus 3 tangent of x equal to 18? So here we have another quadratic. So let's move the 18 over. Well, let's do u substitution here. Let's let u equals tangent of x. So that gives us u squared minus 3u minus 18 equals 0. And we can factor this out. So let's see here. What two numbers multiply to be negative 18, but add to be negative 3? That's probably going to be 6 and 3. This is negative, so the negative one is bigger. That'll be a plus 3. So this will be u minus 6 times u plus 3 equals 0. So that tells me that u is equal to 6 or u is equal to negative 3. Bring tangent back in, and so we will get tangent of x equals 6 or tangent of x equals negative 3. So the second inverse tangent of 6 is, so x equals 1.406 plus pi k. We don't have to worry about the reflections for tangent because tangent is as a period of pi. And then we'll do inverse tangent of negative 3 as well. Negative 1.249. So we'll also have negative 1.249 plus pi k. There we go. Okay, I will see you guys in the next recording.